Welcome back, guys. Today's lesson is on lowest common multiples, LCM, using the factor method. Let's dig in. In our previous lesson, we defined LCM as the smallest number that is a multiple of two or more numbers. And then we learned how to find the LCM of numbers using listing the multiples method. In today's lesson, we'll be finding LCM using the factor method. And now, because I've mentioned factor, I'm going to quickly define it as any number that can divide a given number without a remainder. A factor is something that's entirely new to you. Please do wait to check out our video on factors to help you understand better. Now, let's get into using factor method to find LCM of two or more numbers, starting with the example on our screen. To find the LCM of 8 and 12, I'm going to write them out like this: 8 and 12. Then I'm going to go ahead and draw a line here. Please use a ruler, guys, when you draw this line in your books. So I'll be using factors. I can use any factor or any number that is a factor of either one of them. It doesn't have to be a factor of both of them, but it has to be a factor of at least one of them to find the LCM. And note that we're not just going to use any kind of factors, we use the prime factors. So these are just factors that are prime numbers. And the prime number is a number that has only two factors, one and itself. So the first one we're going to use here, I like to start small and go from there. I'll start with the smallest one. Since they are both even numbers, I'll start with 2. 8 divided by 2 will give me 4. 12 divided by 2 is 6. We still have even numbers, so I'll go with 2 again. 4 divided by 2 is 2. And 6 divided by 2 is 3. I still have one even number, so I will still use 2 again. 2 divided by 2 will give me 1. Now 3 divided by 2 will have a remainder, so I'm not going to perform that division. I will repeat 3. And now I have 1 and 3. This is an odd number. There's no point using 2 again because it would have a remainder. So I'm just going to use the next number that can divide this without a remainder, and that's 3 itself. So put 3 here. And because we've arrived at 1 here, we are done with this line of division. So I'm going to repeat 1. And now 3 divided by 3 will give me 1. So when you arrive at 1 and 1, you're done with the division. So to find the LCM, what you have to do is to multiply these factors that you use to perform the division. So I will say LCM is equals to 2 times 2 times 2 times 3. This factors here. So therefore, our LCM is equals to 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 will give us 24. So that's how to use the factor method to find the LCM of given numbers. Let's go ahead and look at another example. We have 12 and 20, and we're going to find the LCM using the factor method as well. So just as we did in the first example, I'm going to go ahead and write 12 and 20. And because they are both even numbers, I'll start with 2. 12 divided by 2 give me 6. 20 divided by 2 will give me 10. I'll use 2 again. 6 divided by 2, 3, and 10 divided by 2 will give me 5. Now we have two odd numbers, so there's no point using 2 anymore. It's going to have a remainder every time. So let's use the next factor that can divide either one of them. And because I like to start with the smaller one and go from there, I'll use 3. 3 divided by 3 will give me 1. And we're not going to perform the division of 5 because 5 divided by 3 we have a remainder. So I'm just going to repeat that. And to perform this division, I'm going to move to the next factor that I can use. So that would be 5. Remember, we have already arrived at 1 here, so we're done with this division. I'm just going to repeat 1. And then 5 divided by 5 will give me 1. So when you have 1 and 1, you stop. And then you multiply these factors that you used to reduce these numbers. So we are going to say that our LCM is equals to 2 times 2 times 3 times 5. So therefore, LCM is equals to 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. So the LCM of 12 and 20 will give us 60. So one more example on LCM using the factor method. We have 9, 18, and 36. So just like we did in the previous example, I will write out 9, 18, and 36. We have one odd number and 2 even numbers. So it's okay to start with 2. 9 divided by 2, we have a remainder, so we're not going to perform the division. We'll repeat 9. 18 divided by 2 will be 9 again. 36 divided by 2 will be 18. We still have one even number here, so I'm going to go ahead and use 2. I repeat 9. I repeat 9 here because they will have a remainder if I divide them by 2. Now 18 divided by 2 will give me 9 again. And now we have odd numbers only. So I'm going to go ahead and use the next factor that can divide them without a remainder, and that's going to be 3. 9 divided by 3 give me 3. 9 divided by 3 is 3. And 9 divided by 3 again give me 3. And of course, the next factor that can divide this without a remainder will be 3 again. 3 divided by 3, 1. 3 divided by 3 is 1. 3 divided by 3 again is 1. And so we've come to the end of this division and we can go ahead and multiply. So we will say our LCM is equals to 2 times 2 times 3 times 3. So therefore, our LCM is equals to 2 times 2 is 4, 4 times 3 is 12, and 12 times 3 is 36. It means that the LCM of 9, 18, and 36 is equal to 36. So that's it, guys, on our lesson LCM using the factor method. As always, I have classwork here for you to try, and you can feel free to submit that to the email on your screen, mathswithmrsspeaks@gmail.com. I'll be happy to look at them, grade them, and send them back to you. If you enjoyed this lesson, please check out the next one in the series, LCM using index method. Thank you guys for watching. Please do well to like, share, subscribe, or follow, and turn on our notifications so that you can know when we post a new video as well. Thanks again for watching, and I'll see you in the next one. Bye.